Here we have one interesting question. We have one function f which satisfies f of x plus y is equal to fx into fy for all x belongs to n, such that your f of 1 is equal to 3 and the summation of fx from x equal to 1 to n is equal to 120, and we have to find the value of n. First of all, let me brief you. Summation of f of x from x equal to 1 to n is actually summation of f of 1 plus f of 2 plus f of 3 and so on. So first of all, you have to obtain all the values. Now, it is already given that your f of 1 is equal to 3. Then, to obtain f of 2, let's use the given condition and take x equal to 1 and y is equal to 1. So, using the given condition, f of 1 plus 1 is equal to f of 1 into f of 1. Now, we already have the value of f of 1, which is 3. So, here we'll get 3 into 3, or we can say 3 square. Similarly, let's try to obtain f of 3. And for that, your x will be 1 and y will be 2. So, you will get f of 1 plus 2 is equal to f of 1 into f of 2. And your f of 1 is 3 and we already get f of 2, which is 3 square. So here we'll get 3 raised to 3. Similarly, to obtain f of 4, let's take x equal to 1 and y equal to 3. So you will get f of 1 plus 3 is equal to f of 1 into f of 3. So you'll get 3, which is f of 1, and f of 3, which is 3 cube. So you'll get 3 raised to 4. So we can say here we have one GP, which is 3, 3 square, 3 cube, 3 raised to 4, up to so on, where your first term is 3 and the common ratio of second term, which is 3 square upon first term, which is 3, is given as 3, which is greater than 1. And summation of fx from x equal to 1 to n is nothing but summation of n terms equal to 120. So for r greater than 1, the formula of summation is a into r raised to n minus 1 upon r minus 1 is equal to 120, where a is 3 and r is also 3. So you'll get 2 in the denominator. So we will get 3 raised to n minus 1 is equal to 120 into 2 divided by 3, or we can say 14 3s are 120 and it will be 80, which is equal to 3 raised to n minus 1. And if we move this minus 1 on the right hand side, it will become plus. So we will get 3 raised to n is equal to 81, or we can say 3 raised to 4. So by comparing the power of 3, we will get n is equal to 4, which is your required answer. Ta-da! Here we have the question of GP. It is given that the sum of some number is given as 315, whose first term is given as 5 and the common ratio is 2, which is greater than 1, and we have to find last term, and for that we need to find number of terms. So let's use the formula of summation of n for greater than 1, which is ar raised to n minus 1 upon r minus 1, where your a is 5, then r is 2, and we have to find number of terms. So in denominator, we'll get 2 minus 1, or we can say 1, is equal to 315. Now for simplification, we have to move this 2 on the denominator of the right hand side. So here we'll get 2 raised to n minus 1 is equal to 63. If we move this minus 1, so here we'll get 2 raised to n is equal to 64, which is nothing but 2 raised to 6. So by comparing the power of 2, we will get n is equal to 6. So we get the value of n and we are ready to find last term using formula of nth term, which is ar raised to n minus 1, where a is 5, r is 2 and the value of n we find as 6. So here we'll get 5. So we can say your last term is equal to 160 is your final answer. Ta-da! Here we have the question of GP and it is given that the first term is equal to 1 and it is also given that sum of third term and fifth term is equal to 90 and we have to find the common ratio. So let's use the general formula of nth term. Your third term will be ar raised to 3 minus 1 or we can say 2. Similarly, sixth term is ar raised to 4 is equal to 90. But we know that your a is 1. So here we'll get r square plus r raised to 4 is equal to 90. Or let's rearrange the term. R raised to 4 plus r square minus 90 is equal to 0. Now we have to create the factors. Let's say your first and last term will be as it is and we need a number whose product is 90 and summation is 1. So it can be 10 and 9. So your middle term will be split as 10r square minus 9r square. So we can say from first two terms we can take r square common. We will get r square plus 10 and from rest of the two terms we can take minus 9 common. So remaining terms are r square plus 10 is equal to 0. So here we'll get r square minus 9 and r square plus 10 is equal to 0, which will give us two possibilities, r square equal to 9 or r square equal to minus 10, which is not possible for any real number. So here we get r is equal to plus or minus 3 as a possible common ratio. Ta-da! Here we have equation of GP and we have to assume three terms of GP. So the preferable assumption for this condition is a by r, a and ar, and it is given that the sum of these three terms will give us 56. Let's say this is your equation number 1. Now according to second condition, we have to subtract 1 from the first term, then 7 from the second term and 21 from the third term. Then they will be in AP. Now if x, y, z are in AP, then we can say 2y must be equal to x plus z, where your y is a minus 7, then x is a by r minus 1 plus your last term is ar minus 21. Now let's open the bracket. We'll get 2a minus 14 is equal to a by r plus ar, and minus 1 and minus 21 will become minus 22. Now from equation number 1 we can say a by r plus ar can be equal to 56 minus a. So if we substitute the value of a by r and ar from first equation, we will get 56 minus a minus 28 is equal to 2a minus 14, or we can say collect the terms of a on the left side will give us 3a is equal to rest of the terms will give us 48, or we can say your a must be 16. But still, to get the value of terms, let's use your first equation and substitute the value of a, which we find as 16. So we will get 16 by r plus 16 plus 16r is equal to 56, or if we take LCM of r, we will get 16 plus 16r plus 16r square is equal to 56r, or your quadratic equation will be 16r square, 16r minus 56r will be minus 40r plus 16 is equal to 0. So, to factorize our quadratic equation, we need two digits having product is equal to 16 square and summation is equal to coefficient of r, which is minus 40. So, it can be 32 and 8. So, here your first and last term will be as it is. Minus 40r will be split as minus 30r and minus 8r. So, here we'll get 16r minus 8 and r minus 2 is equal to 0, which will give us two cases, r is equal to 1 by 2 and r is equal to 2. And we already find out a equal to 16. So, the terms of GP, which we assume as a by r, a and ar, will be 16 upon 1 by 2, or we can say 32, then 16 and 16 into 1 by 2 will give us 8. Similarly, for r equal to 2, it will be 16 by 2 will give us 8, then 16 and 16 into 2 will give us 32. So, we can say our required numbers are 8, 16 and 32. Ta-da! In this question, we have GP consisting of even number of terms. So, let's consider a GP having even number of terms, or we can say 2n terms. Now, in this question, we have one interesting condition, that the sum of all the terms is equal to 5 times the sum of terms occupying odd places. So, on left hand side, we have all the terms, no matter they are at odd place or even places. And on right hand side, we have sum of terms at odd places, or we can say first term, third term, fifth term up to 2n minus 1 terms. Now, on left hand side, we have the first term is equal to a, then the common ratio is equal to r, and the number of terms is equal to 2n. So, if we consider r greater than 1, then the formula of summation will be a into r raised to n minus 1 upon r1 minus 1, where your a is small a, then the common ratio is r, and the number of terms is 2n. So, in denominator we will get r minus 1. Now, on right hand side, we have GP having first term is equal to a, then the common ratio between second term, which is ar square, upon first term, which is a, is actually r square, and number of terms is actually half of the total number, or we can say n. So, the formula of summation of this series is a into r2 raised to n minus 1 upon r2 minus 1, where your a is small a and the common ratio is r square. So, denominator will also become r square. So, here your a and r raised to 2n minus 1 will be cancelled out, and we will get 1 upon r minus 1 is equal to 5 times 1 upon r square minus 1, which can be factorized into r minus 1 and r plus 1. So your r minus 1 will also cancel out and you will get r plus 1 is equal to 5, or we will get common ratio is equal to 4. Is your final answer. Ta-da! In this question, we have one interesting condition that a plus bx upon a minus bx is equal to b plus cx upon b minus cx is equal to c plus dx upon c minus dx, where x is not equal to 0. And we have to prove that a, b, c, d are in GP. So let's try to separate the terms, and for that we have to take componendo dividendo, in which to form our numerator we have to take numerator plus your denominator, and in denominator we have to take numerator minus your denominator. Similarly, we will form second term and third term. So if we simplify, px will cancel out, we'll get 2a upon a will cancel out and we'll get 2bx. Similarly, in second term, we'll get 2b upon 2cx, and in third term, we'll get 2c upon 2dx. So your 2 will cancel out and x will also cancel out, and if we reciprocate the terms, we'll get b by a is equal to c by b is equal to d by c, or we can say the ratio of corresponding terms is equal to each other. So we can say a, b, c, d are in GP. Hence proved. Ta-da! Here we have one question based on n terms of GP. So let's consider GP having first term is equal to a and common ratio which is r. Now it is given that your s is sum of n terms, and we know that if we consider r greater than 1, then the formula of summation is ar raised to n minus 1 upon r minus 1. Then the next quantity is given is p, which is product of all the terms. So we have a n times, so we get a raised to n, and the power of r are 1 plus 2 plus 3 up to n minus 1, and we know that summation of n natural numbers is given as n into n plus 1 by 2. So we can say summation of n minus 1 natural number must be n minus 1 into n minus 1 plus 1, or we can say n by 2. So here we'll get p is equal to a raised to n and r raised to summation of n minus 1 natural numbers, which is nothing but n into n minus 1 by 2. But to prove our thing, we need p square. So it will be a raised to 2n and r raised to n into n minus 1 by 2 into 2, or we can say both will be cancelled out. Now the third term, which is denoted as r, is sum of reciprocals of our terms, which is actually sum of GP terms having first term is equal to 1 by a, then the common ratio between second term, which is 1 upon ar, to the first term, which is 1 upon a, will be 1 upon r, and we already assumed that r is greater than 1, so we can say our ratio will be less than 1, and the number of terms are r. So summation of this formula is given by a into 1 minus r raised to n upon 1 minus r, where the first term is 1 by a and the common ratio of this series is 1 by r. So here we'll get 1 upon r raised to n upon 1 minus 1 upon r. So let's simplify. 1 upon a, take LCM of r raised to n, multiply with 1, we'll get r raised to n minus 1 upon r raised to n into, in denominator, take the ratio of r, we'll get r minus 1 upon r, but the denominator of denominator will move in numerator. So we can say your r must be 1 upon a, this r raised to n minus 1 upon your r minus 1, and r raised to n and r will become 1 upon r raised to n minus 1. But as you can see, we need r raised to n. So let's take n power on both sides. So let's begin from the left hand side, which is p square into r raised to n. So let's get your p square and multiply with r raised to n. So here a raised to 2n upon a raised to n will become a raised to n. Then r raised to n into n minus 1 will cancel out, and your this terms will be as it is. Or we can take the power of n common, which will give us s raised to n, which is equal to p square into r raised to n. Hence prove. Ta-da! In this question, it is given that A, B, C, D are in GP. So we can consider A as the first term of the GP and R is the common ratio. So we can convert A, B, C, D in terms of A and R. Now we have to prove that your X, Y and Z are in GP. That means we have to prove that your y square is equal to xz. So let's begin from the left hand side, which is y square, or we can say b raised to n plus c raised to n the whole square. So let's take n power on both sides. So we will get b raised to n as a raised to n into r raised to n plus your c raised to n is a raised to n into 2 raised to n the whole square. So from the bracket we can take a raised to n and r raised to n common. So we'll get 1 plus r raised to n within the bracket, and if we apply square we will get a raised to 2n, r raised to 2n into 1 plus r raised to n the whole square. Similarly, let's try to obtain your right hand side, which is x into z, where your x is a raised to n plus b raised to n, and z is c raised to n plus d raised to n. So let's take n power on a and d. So a raised to n will be as it is plus, let's get your b raised to n, which is a raised to n into r raised to n, and your c raised to n is a raised to n into r raised to 2n plus a raised to n into r raised to 3n. So from first bracket we can take a raised to n common. So the remaining terms are 1 plus r raised to n, and from second bracket we can take a raised to n and r raised to 2n. So we'll get 1 plus r raised to n. So here we'll get a raised to n into a raised to n will become a raised to 2n. Your r raised to 2n will be as it is, and 1 plus r raised to n into 1 plus r raised to n will be 1 plus r raised to n the whole square. So as you can see, your left hand side is equal to right hand side. or we can say b raised to n plus c raised to n the whole square is equal to a raised to n plus b raised to n into c raised to n plus d raised to n. Therefore, we can say these terms are in GP. Hence proved. Tada! In this question, it is given that a and b are roots of this equation and c and d are roots of the second equation, and it is given that the terms a, b, c, d are in GP. So we can assume a as a first term and r is common ratio. So your b will become ar, then c will be ar square, and your d must be ar cube. Now your first quadratic equation, which is x square minus 3x plus b is equal to 0, having roots of a and b. So we can say the summation of the roots must be equal to the coefficient of x, and the product of roots must be equal to constant term, which is b. Now a is a and b is ar. So here we'll get a into 1 plus r is equal to minus 3. Let's say this is your first equation. Similarly, a into ar will be p, or we can say p must be a square into r. Let's say this is your equation number 2. Now let's move to your second quadratic equation, which have c and d as a roots. So we can say the summation of roots must be equal to the coefficient of x, which is minus 12, and product of roots must be equal to constant term, which is q. Now let's substitute value of c and d, which is ar cube, will be equal to minus 12. So here we can take ar square common and you will get 1 plus r is equal to minus 12. This will be your equation number 4. Similarly, your c into d is q, which will give us q is equal to a square into r raised to 5. This will be your equation number 4. Now, to get the value of a and b, we have to solve equation number 1 and 2. So, let's take a ratio of equation number 3 and equation number 1. So, your a and 1 plus r will cancel out. We will get r square is equal to 4. Now, we have to prove that q plus p upon q minus p is equal to 7:15. So, let's begin from the left hand side, which is q plus p upon q minus p, and substitute the value of q and p in the numerator. So from numerator we can take a square into r common. We will get r raised to 4 plus 1, and from denominator we can take a square into r. So we'll get r raised to 4 minus 1. So your a square r will cancel out. Substitute the value of r square, which is 4. So here we'll get 4 square plus 1 upon 4 square minus 1, which is nothing but 17 upon 15, which is your required right hand side. So we prove that your left hand side is equal to your right hand side. Ta-da! Here we have one interesting question. It is given that ratio of arithmetical mean and geometrical mean of two positive numbers a and b is m is to n, and we have to prove that a is to base this number. So first of all, let's find out arithmetical mean of AB, which is A plus B by 2. And now we have to find geometrical mean, which is under root of AB. And it is given that their ratio is equal to m:n. So here we'll get A plus B upon 2 times under root of AB is equal to m:n. Now, to separate A and B, we have to take componendo dividendo. So, in numerator of the left hand side, we have to take numerator plus denominator upon numerator minus denominator. Similarly, on right hand side, numerator plus denominator and numerator minus denominator. So, on left hand side, we get x square plus y square plus 2 times xy, or we can say the whole square of root a and root b. Similarly, in denominator, we have whole square of root a minus root b is equal to m plus n and m minus n. Now, to remove this square, we have to take root on both sides. So, we'll get under root of m plus n and under root of m minus n. So, we get root a plus root b and root a minus root b. And to separate root a and root b, we have to take again componendo dividendo. So, let's do it. In numerator, we have to take numerator plus denominator, and to form denominator, we have to take numerator minus denominator. Similarly, we will form right hand side. So, on left hand side, your root b will cancel out and we will get 2 times root a upon root a will cancel out and we will get 2 times root b is equal to, your right hand side will be remain as it is. So, here your 2 will cancel out, and to get a by b, we have to take square on both sides. So, we will get a by b. But in right hand side, we have to expand it. The square of root m plus n plus 2 times under root of m plus n into under root of m minus n plus the square of under root of m minus n. Similarly, we will form our denominator. So, here we'll get m plus n plus 2 times under root of m plus n into m minus n, or we can say m square minus n square plus m minus n, and in denominator we'll get m plus n minus 2 times under root of m square minus n square plus m minus n. So, here your n will cancel out and we will get m plus m, or we can say 2 times m plus 2 times under root of m square minus n square upon 2 times m minus 2 times under root of m square minus n square. So, your a by b will be equal to m plus under root of m square minus n square upon m minus under root of m square minus n square. Hence proved. Ta-da! In this question, we have so much conditions. Your first condition, it says that 3 terms ABC are in AP, and the necessary condition for this is B is equal to A plus C by 2. Let's say this is your equation number 1. Then the second condition is about GP. Your B, C and D are in GP, and the necessary condition for this is the middle term should be equal to under root of product of first and third term, or if we square both sides, we'll get c square is equal to dd. Let's say this is your equation number 2. Now, the third condition is again about AP. 1 upon CE, 1 upon D and 1 upon E are in AP. And for that, middle term should be equal to summation of first term and your third term by 2, or we can simplify your D as 2 times CE upon C plus E. Let's say this is your third equation, and we have to prove that ACE must be in GP, and for that we have to prove that C square is equal to A into E. So we need relation between C, A and B. So we have to eliminate B and D, which can be possible using first and third equation. So let's take equation number 2 and substitute the value of B and D and try to simplify. Here your 2 will cancel out. On left hand side we have C square. So 1 power of C will also cancel out, and let's cross multiply. C into C plus E is equal to A plus C into E. So open the bracket, you will get C into C, or we can say C square, then C into E will give us CE. On right hand side, E into A will give us AE and E into C will give us CE. So your CE will be cancelled out. You will get C square is equal to AE. So we can say A, C and E are in GP. Hence proved. Ta-da! In this problem sum, it is given that a person writes a letter to 4 of its friends, and he asks each one of them to copy the letter and mail to 4 different persons with the instruction that they move the chain similarly. So we can say in first chain, number of letters mailed is 4. Assume that chain is not broken and it cost 50 paisa to mail 1 letter. So we can say the cost to mail will be 4 into 50 paisa, or we can say half rupee. So we can say cost to mail 4 letters is 2 rupees. Similarly, in second chain, number of letters will be 4 into 4, or we can say 16, and cost for it will be 8 rupees. Then in third chain, 16 persons will be mail 4 letters, so they will be reached to 64, and the cost for this will be 32 rupees, and so on. The chain will not break. So as you can see, the cost to mail the letter is in GP. Your sequence is 2, 8, 32 and so on, where your first term is 2 and the common ratio of second term to the first term is 4, which is greater than 1. And we have to find amount spent on postage when 8th set of letter is mailed. So to find total cost at 8th step, we have to find S8. And for R greater than 1, the formula will be A into R raised to 8 minus 1 upon R minus 1, where your A is 2, then R is 4 and N is 8. So in denominator, we'll get 4 minus 1, or we can say 3. So your total cost will be 43690 rupees is your final answer. Ta-da! In this problem sum, we have a man which deposit 10,000 rupees in a bank at the rate of 5% simple interest annually. Here, your interest rate is simple. Remember this thing. And we have to find amount in 50 years since he deposit, as well as total amount after 20 years. So, amount he received in 15th year will be deposit plus simple interest of 40 year at the rate of 5%. So, he deposit 10,000 and simple interest on 10,000 at the rate of 5% for 14 years. So, this 5% is actually 5 by 100. So, we will get 10,000 plus 7,000 interest. So, total amount he received is 70,000 rupees. Is your first answer. Now, let's calculate amount after 20 years. Using the same formula, deposit plus simple interest for 14 years of the rate 5%. So, your deposit is 10,000, then simple interest on 10,000 of the rate of 5%, or we can say 5 by 100 for 20 years will be calculated as 10,000. So, it will become 20,000 rupees. Is your second answer. Ta-da! In this problem, we have one manufacturer which reckons that the value of machine which cost him 15,625 will depreciate each year by 20%. So we can say at the end of first year, its value will be the original cost, which is 15,625, and depreciate by 20% of its original cost. So here we can take 15,625 common and we'll get 1 minus 20%, or we can say we will get 15,625 into 0.8. Similarly, at the end of second year, the cost will be original cost into 0.8 raised to 2. So we can say at the end of 5 years, the cost will be 15,625 into 0.8 raised to 5, or we can say 5,120 rupees is your answer. Ta-da!